All right. Good morning, everybody. Welcome to the May 30th, 2025 working group meeting. We'll start off this morning with new members. They're not on the list. However, I did see that they are here. We've got Tara Joden. I saw was on the call. Tara, if you wouldn't mind just introducing yourself to the group, who you are, what brings you here.
Hi, everyone. Can you hear me?
Yes.
Okay, great. Yeah, so I'm very happy to join this working group. So my deputy director, Giuliano Toluso, is already a member, and also Kyle Kerstead, who is a senior analyst with Agriculture and Agri-Food Canada. So I focus mainly on controlled environment agriculture. And there's some new emerging sectors as well, cellular agriculture and precision fermentation, where robotics come into play later on in the future.
Excellent. Well, thank you so much for joining. Appreciate you having you here. Um, that is in terms of our lists for this week. That's everyone I see. Unless I am missing somebody or is if there's anyone here who has not introduced themselves before that would like the opportunity to.
Yes, good day. It's William Coble. I was introduced by Keith Ellis from Vertical Data, and we have a patent pending AI technology that reduces hallucinations, and you get the real accurate information. And excited to be here and just listen to your group and see how we could maybe fit in.
Excellent. Wonderful. Thanks so much for joining us, William.
Yes, thank you.
I think did I see a hand with Kate Withers?
Yes, hi Dan. Thank you so much. Hi Agrobotics Working Group. Lots of familiar faces on the call. Hi Joe, Lisa. So I'm a strategic advisor and co-founder to Saiwa.ai, and we are a drone-based monitoring ag tech company. And right now we focus on detecting invasive species at the plant level or like noxious weeds, and then being able to create maps that drone sprayers could then go and spray, or ground sprayers could then go and tackle. And we're working also on some greenhouse and horticultural projects as well. Thank you.
Excellent. Thank you, and thanks so much for joining us. I see Frank from Studica.
Yes, hi. Uh, I'm actually not feeling great. But the good news is I got COVID coming back from China, but I won't spread it to you guys, so that's a good part. But anyways, yeah, it's very mild, so I think I can talk. Just want to say hello to everyone, introduce myself. My name is Frank Nanfera, president of Studica Robotics. And what we do is educational robotics. So we actually develop robotic systems, controllers, IMUs, etc., for education, and we're doing also commercial. And over the last couple of years, we started getting involved with agricultural robotics. One of the things that we did is we have this competition that we ran, which was an international competition with World Skills. And it was, we had something called the Leon competition, where all these different teams from different countries around the world were actually making robots that were going to be able to pick grapes, select different fruit and vegetable colors, planting seeds, and different things like that, and using our equipment, our controller, our kits. And early this year, we actually got involved with RoboCup, which is an international robotics competition, and we developed something called the Smart Farming Collection, where they're using our collection to make robots for different robotic competitions that they're running. So we're doing that. We have a lot of great products coming out, and when I found out about your group, I was really interested. I thought, wow, we can really either work together or learn from you guys or help you guys, etc. So that's why I'm here. If you guys are interested in, just look up Studica, go to studica.co, which is just our Studica robotics site, and you'll learn about our kits and our products, our controllers. We have new products coming out. Anything, if you have any questions, just reach out to me. Thank you.
Wonderful. Thanks so much, Frank, and hope you feel better soon. I saw a hand up there, Fadi.
Hi, Dan. Hi, everyone. I'm Fadi Al Daoud. I'm the greenhouse vegetable specialist with the Ontario Ministry of Agriculture, Food and Agribusiness. This is my first working group meeting. My colleague Catherine Russell is a regular in these meetings, and she told me about the greenhouse topic today. So if it's okay with everybody, I'll be popping in whenever there's a greenhouse relevant topic. Thanks very much.
Excellent. Sounds great, and thanks so much for joining us this morning. All right, perfect. Well, with that, I think we'll move on over to our presentation for today. So today we're joined by Konrad Konnerth of Konnexio, local here in London. And Konrad, please take it away. Oh, sorry, you're muted.
Sorry about that. I was just about to share and I missed my unmute button. Can you hear me now?
Yes, we can hear you.
Yeah, wonderful. Okay. Well, first of all, thank you very much for having me here today. It's a pleasure to talk to this group and to kind of show everybody kind of where we are right now at the moment in our development. Do I still share or did I take it off?
We cannot see your screen at the moment.
Okay. Okay. How about now?
Yes, you are up and running.
Perfect. Wonderful. Yeah, so I want to talk a little bit about building blocks and that we're working on and a roadmap towards greenhouse robotics. And I guess right off the back, when I'm looking at this first picture there, it's a little bit of well, it doesn't show a greenhouse, first of all. It's actually an outdoor farm, but that's just details. So yeah, we've been maybe first I'm going to start off. I'll get my controls here. There you go. Maybe I'll just introduce ourselves a little bit, who we are as a company. Just take about maybe 5 minutes to show you in general what we do or what we've done before we get more into the ag side of it, of the business. But I think it helps bring everything a little bit together. We're established as a company in 2003. We incorporated then, and our main focus has been and still is to some extent custom engineered automation systems. So we build based on customer specifications. We would be building machinery for them, a lot, of course, in the manufacturing industry. And then I'll talk a little bit more about the Adapto and which is our industrial side of it, and then the agri trucks, which is kind of the robotics, the agricultural robotics side of it. So custom automation is really very much, as the word says, it's very much custom built. So you're basically taking a contract from a customer to design and manufacture a piece of machinery. It's pretty much one-off. There's not much repetition there other than your experience, obviously, that you have from past projects. But of course, these are, and quite often they also involve retooling projects from existing machines that are out there already. And we did that for about a good 10 years. Now, the goal always had been when I started Konnexio, the dream was always to have some kind of a more of a standardized piece of equipment. I saw some real difficulties in machine building, and people know that, of course, it's very much of a up and down. Sometimes you don't really know exactly from project to project how successful it's going to be. And so we had this vision of developing like a pre-engineered machine. Finally, after 10 years of being in business, we then actually decided, okay, we have to get moving on this. And it still took us about another 5 years to develop that concept or that base machine system, basically. 2018, we first shipped our first machine from that functionality that we called Adapto. And really what it is, it's a pre-engineered solution. So what you have is you have pretty much 80% of this machine is actually already in place. It's engineered. Very often we have it pre-built and we're just using it to tool up for the actual applications that our customer want us to do. They're very modular in itself. And when I'm saying modular, they're not just physically somewhat look modular, they actually each one of these cells, as you see there in the top top right-hand side, this machine is actually, it's about 10 cells, but literally all of these cells are actually own machines, they're individual machines. That makes it truly modular. So if something changes, we can pop a cell out, we can add some cells to it. So it really makes it much, much easier to upgrade, to modify, and so on. And also it helps us to build it actually quicker. That was the main reason for this. So what we calling the system really being scalable. It's very a scalable system where we don't ask our manufacturers, our customers, to really predict too much in the future. We just always tell them, just think about what would be the most valuable part right now at the moment, and then we can just add more cells over time without having to think about too far in the future. A lot of industries in this area are basically automotive, of course, medical device. We've actually done some ag applications as well, and I will show you some of those. And then a lot of it is nowadays in energy storage, like hydrogen fuel cells, and we're trying to get more into the battery side as well. Very quickly, this is like a typical machine, how I would like when it's functioning. Again, very mechanical, very much out there. But again, all these motions that we're driving, they are all servo-driven. They are robotics motions. They're not pneumatic. So they're very much controlled motions. Typically, we achieve up to about 2-second cycle time with this kind of machinery. So it can be very, very fast, but it can also be slower depending on what the application. Of course, the processes sometimes may take longer, but the machine itself is capable of about 2-second cycle time. And then we did actually do a soil dispensing machine, which is kind of a little bit more ag related on the same base system. So here we did some volume metering. So we dispensed soil and made sure it's the right volume, the right, actually by weight we went by. And this machine could handle various sizes of volumes that we had to handle. And it also had various crucibles and trays that we had to handle as well. We did actually use the existing wood pallets that the soil samples actually did come in. So we didn't ask the customer to have to replace all these. And this, of course, was programmable depending on which volumes they need to scoop. You can actually program that on the machine and tell them what you want to do. In its full capacity, the machine is capable of doing up to 24,000 dispensings per shift per day. Of course, on each of the cells, we have multiple cells in there. And the big kicker is for most of our automotive customers, they always kind of are amazed by that because this customer actually has no maintenance department. Very often in most of our current or industrial applications, they have maintenance departments and they're used to keeping the machines up and running. While because of the pre-built scenario, the way our machines work, having pre-built and having tested them, there's very little maintenance required. So a machine like this kind of functions something like that. Again, the tooling on here, the actual soil scooping, is a completely custom to this application. But the motion and the handling of the machine, the way the machine is set up and the way the machine is functioning, is actually a standard. It's a little bit like when you buy a robot, an industrial robot, you know what the functioning is of the machine, you know what the machine is, what the robot can do, the payload, the reach, the speed, the programming is involved. And that applies very much to our machines too. So the machine has very much as capability. What you need to put on is basically the tooling, what you want the machine to do. Very similar to a robot. When you buy one, you still have to tool it up and tell it what to do. So yeah, that's a little bit on the ag side, on the base machine systems that we are building industrial. But now let's get more into the agri trucks, into the robotic side of it. We got actually Greg from A&L. He has a little bit of challenge for us. At one time we chatted and we talked about it, and then he said, well, he does have a lot of drones going over fields and inspecting the stresses and the fields and so on. He said, but I cannot get into the greenhouses because you cannot use drones in greenhouses. So he asked me, can you build a system that can get a vision camera on top of high wire pepper plants? How would we do that basically? How would we get up there? And of course, the pepper plants in a greenhouse, they grow up to 15 feet high, plus you need a little bit above that. So how would we get a camera up there and then of course go to the whole rows and inspect and kind of use that for scouting. So that was kind of the initial challenge, and we worked on this and get a little bit more into the details how we're actually doing normally developments of systems. But you see in the bottom right corner of that picture, you start off very crude, obviously. So it's not uncommon that you're testing a few things, you're trying a few things to get some elementary work done. And so it looks very unprofessional. Our industrial machines look nothing like this, but we didn't really know what we're getting into. We didn't really understand all the ins and outs, and we weren't really paying full attention on the on all the making the work neat at that stage. In the upper right corner, you see a little bit of, that's kind of how it worked a little bit. One guy programming and three guys standing beside him and waiting for something to happen. So it was very indicative of those days back then initially when we started out with this. But what we actually focused on this system, from our point of view, from Konnexio's point of view, we wanted to find a way how we can have an easy maneuverable system. And so we used mechanical wheels for that to be very agile in the greenhouse to drive. And of course, we had to get it on and off the rails. In this case, in this greenhouse, they had rails in there. And so we had to seamlessly drive on and off those. As I mentioned before, the vision cameras had to be very high up. So we developed a mast that could collapse down to 7 feet to fit into a truck, to fit into underneath all the overhead wiring and so on that was in the greenhouse, but then of course extends up to 15 feet high and could handle a capacity, could actually carry some load. Of course, we were thinking right ahead further. We were thinking of carrying maybe 100 kilograms and not just 5 kilograms like a camera weighs, but actually do much more than that. So we always planned for much bigger load that we could carry up to the top. The idea was maybe some point in time we get more into robotics harvesting or robotics tending to the plants or something like that. And what was very important too, because I will show a few pictures later on, but in a greenhouse it can be very crowded in terms of the plants. They grow very much over top the aisles. And so we wanted to have the cable management all inside, so nothing gets ripped off, nothing gets torn off, so to keep it nice and neat. So everything, all the cable runs actually inside the mast and is protected from that. On this specific version here, then we added some arms that extend over and above, kind of flips out over top the canopy, and an additional 3 feet because the mast could only reach 15 feet in this case here. So that was our initial kind of system that we kind of built. And I'm showing here a little bit how nicely those mechanical wheels actually are really good for maneuvering. So when you turn them, they can really swivel quite nicely on the spot and quite easily. Yeah, so they're quite nice from that point of view. And here just show you that you can drive on and off the rail. I guess we weren't fully aligned there, but it still finds its way onto the rail quite easily. And there's really a seamless driving on and off. There was no hesitation there or issue there. And it did, of course, autonomously as well. Here it shows a little bit how it drives along on a rail, for example. It can go pretty fast, and it's, of course, when you go forward here in the scouting area, then you would go fairly slow. Here we're showing this in the second picture on the right side, the second video. So it's a little bit hard to see, but the robot actually comes towards you, and the very, very top, there are 2 cameras there mounted on there. It's maybe a little bit hard to see, but of course, with the light there against the sun, it's sometimes hard to identify. So we would be moving always a few meter forward, like 2 feet or so, and then take another set of images, then go another 2 feet, take another set of images. And that was kind of the idea for scouting for stresses in the greenhouse. And we, of course, just to be clear, we actually did not do the camera side of it. We were responsible for the robotic side of it, but we did not do the scouting aspect because we're robotics engineers. We don't claim to know anything about the robotics, sorry, the vision camera side of it, and especially the scouting ideas. And that was kind of the first project. It worked okay. The customer actually did say that our robot was working really great. I mean, it did what it was supposed to be doing. The functionality of the scouting was still took a little bit longer, and I think it's still ongoing right now at the moment. It's a little bit more complex, obviously, than that. But like I said, the customer gave us really good feedback on the robot and the way it worked and behaved. A few years later, we then started to talk about another application for UVC strawberries. And actually, that is a project right now we're just implementing at the moment. So we started about a year ago on this project. And so here we really, it was a little bit different, even though I said we want to focus on greenhouse. Actually, this is actually an outdoor application. But as much as it's outdoor, it still fits very well with what we're trying to accomplish and where we want to go. But of course, the outdoor makes it a little bit harder sometimes in some aspects, and we had to learn the hard way, unfortunately. So here the base system had to be maneuvering on the field conditions, and I will show a few samples of what that means. I guess you all know, but it can be sometimes challenging for a robot. And it had to fit between those tabletop posts. As you can see, there's not that much space. It looks decent for a human, but for a robot to make sure it can steer along those things, it's not always that simple. So we basically have on each side of the post, we have only about 4 inches space left that we can move her along. And so the navigation was a little bit of a challenge, or is still a little bit of a challenge. We're just finalizing that right now to following along the aisles. It's basically they're about 300 feet, I think, long or so. And of course, recognizing the end of the aisle and then returning back home again. So what we're doing is we go on one side, we're applying the UVC. Of course, it has to be nighttime. This is right now, we're just testing it at daytime. And then switching over to the other side, returning on the other tabletop when we're returning back home again. And then we had to implement UVC lamps and the electrical system into this rover. So that was a little bit of a new thing as well. And of course, the movement of the UVC lamp hood where all the lamps are installed there. We did, however, as I indicated, had a few challenges that we were kind of underestimating. And that was really the conversion from the mechanical wheels to the skid steering. The rover, we just thought we put other wheels on there and reprogram the steering kind of a thing a little bit and tweak it and work on it, and far from it. It was way more complicated. What we found was there were actually some major issues that we had overlooked and underestimated. One was the torque on the motors wasn't really far from being sufficient. The wheelbase geometry actually contributed to the issue. And the tires, of course, from a traction point of view, had to be beefed up as well. We knew that, obviously. So at the end of the day, it took us a good few tests and a good few different iterations to get to that stage where we finally got this rover actually moving quite nicely. It has now, of course, a wider ATV style tires. We had to do a new motor gearbox and programming for this, a completely new system in there. We had to modify the wheelbase geometry, actually bring the two wheels closer together because we had them too long apart and they would fight each other. We could not get them to work that way. But of course, because the wheels are wider, we also had to redevelop the complete frame as well, because on the greenhouse, they were further out, and now we had to bring them further towards the center. So the whole frame had actually to change, and we had to change the orientation of the wheel. So there was a lot of impact on that. The bigger motors and the bigger torque also required more battery power, so that impacted it. And of course, like I said, we were kind of going step by step on this. But the result was still, and this was actually an image taken last fall, because we wanted to make sure we're on the right track before we're going to do all the rest of the work. So as you can tell, now this thing actually moves and it actually can rotate and has enough torque and has enough functionality to do what it's supposed to be doing. So this is kind of where we are right now at the moment. So this is actually running autonomously, although our guys are following it just to make sure it is safe. We're still in the testing phase and the implementation phase right now at the moment. And there's always little things that you need to tweak and need to adjust. But you see all the unevenness, and with the mast there holding all the UVC hood, it has to be sturdy enough to handle all these things. And of course, the same thing when it goes into the greenhouse. If you work on 15 feet high high wire applications, again, the system has to be sturdy to actually handle all these applications, especially if we get into some kind of a robotic harvesting or some robotic motions, for example. There's another example, and of course, like I said, and this is actually not bad. I mean, I assume this is probably as good as it gets for a farm, from a soil, preparation point of view. So we had to kind of test it and try and make sure it's all safe and it doesn't, fall over or anything like that. But it is sometimes challenging for us, and we need to, verify all these things. So where we are right now at the moment with this project is it is actually now functioning. We're just finalizing the navigation part of it and testing it all out and following it. What is going to be happening next is next week we're going to have OMAFA work with us to actually set the right dosage, the UVC dosage, and then we're going to start measuring that. They will also develop a plan on the strawberries to verify. So we're going to do a controlled environment where we're doing certain aspect of, no UVC and just chemicals, some areas UVC and chemicals, and some areas just UVC, and kind of verifying what the different impacts are on the strawberry plants. And OMAFA will then measure basically the efficacy on the UVC, but they will, help us set the dosage on this. We do have a few more things we would like to implement at some point in time, which we haven't had time or be able to do so far, which is we want to integrate active suspension into the system. We actually have planned for it, and it's actually all installed and wired, but it's not being programmed yet at the moment. What it actually would do is it would actually measure the condition of the rover and would readjust each one of the four wheels individually to always keep the rover balanced. Again, it was kind of just a timing point of view that we haven't been able to get to that. But as the rover keeps, because obviously application, and this one here will be at nighttime. So we'll expect to do, when it starts going to operation, we have the daytime still to do other things to, kind of work on improvements and do other systems that we can integrate into the system. We do want to integrate some vision cameras as well. At this stage, there's no mandatory requirement for that, but we would like to have a look at the plans and kind of plan for future applications to see what can we actually see. Is there something we can track from there, something is there any data we can get from there? I'm a firm believer of let's just start easy without having a full commitment to something, but let's just get an understanding, okay, what can we actually identify and what's actually out there. So all of this, made me think a little bit. Actually, it's been probably about 2 years now in the thinking for myself, where I kind of reflect a little bit on the developments between industrial automation and robotics. And I pretty much feel like there's somewhat of a difference, although they sound very similar. But for me, I find that the one side is a little bit more engineering, and the other side is literally more invention than engineering. on the industrial side, you started with a very clear specification. The customer tells exactly what he wants, and there's parameters. It's all pretty much identified up front. While I find in robotics, it's really people more provide you with a problem or with an opportunity, basically, and you're trying to work around that. Very often, it's more an ingenious solution. And what I've found was I'm always fascinated when I talk to growers or farmers because they have actually very simple or very good ideas for very simple ideas for problems, while engineers sometimes think way too complex, way too difficult sometimes around. So I find it's not always easy, not always helpful to have people from industrial automation sometimes work on those things. You need to have a little bit see what's out there, what actually works. Can be much simpler sometimes. The developments in engineering are very much of a parallel development. You know what you need to accomplish. You build the machine, design the machine, you manufacture it, and you build it pretty much all at the same time, and you put it together. While I find in at least from our point of view, when we built the robotic side of it, it really was kind of more sequential feature development. You had to kind of think about one feature at a time, test it, try it, make sure it works, then move on to the next one. It was very, very hard to do them all at the same time. You really get over your head and you kind of find you're losing track of things and nothing really ends up working. So therefore, in industrial automation, it's pretty much mapped out your path, your plan, how you're going to go to a finished machine, where I find in robotics, it's a little bit non-linear. It's full of obstacles, and very often there's stuff that at least we have never done before, and we had to kind of try and develop from there. And of course, it's also in industrial, it's a controlled environment. We very often, the parts that we need to put together, or the processes are very much much more controlled, where in the field, we have very little control of those things. Sometimes there's rain, there's different soil conditions, there's different plant conditions. So all these things are very, very hard to sometimes plan for. So it's not always as easy. I also found that, of course, the way these things are procured, or how you make as a company, how you make money, is also much, much different. In industrial automation, you do sales and marketing, and you get the job, you build it, and then you collect your revenue. But the job, the building, the development is actually your revenue. While in this side of it, I'm still struggling with that, because farmers are not really interested in developing stuff. They're really more interested in getting a product that's finished. So we need to think about, what actually makes sense. How do we develop? What do we want to develop? What is actually valuable to farmers? And then try and sell it and then produce it, hopefully in batches, because producing it one-off, again, is very expensive and probably not worthwhile. So it's more like a batch or like a volume production, and then get to revenue. So all these things are a little bit different. So our approach has been for pretty much both in Adapto and Agritrax is to standardize and then to adapt. So we don't like to go out and at least if I go out and these have been so far just R&D projects mostly, not actually committing to customers a full deliverable product at the moment in the ag side. But we like to know what we're going to be promising, and we like to figure out how we deliver on that. So we always like to try with a pre-engineered and tested system that we actually know how it's going to be performing, at least to 80%. There's always some stuff that needs to be adapted towards it, but at least we don't want to start with a blank sheet. And then we want to continue on and improve those features on the system over time, because we want to make it better and better and get more features into this. And then, of course, we also trying to improve the cost and bring more value to those systems that we're sending to our customers. And the adapting side of it is, of course, we're customizing it to their specific applications. In this case, for example, we're hoping, for example, that the rover base, the mast, and the whole system functioning the way you're driving it is all standard more for us. And then putting different applications onto this, let's say UVC, scouting, hopefully robotic harvesting, and other things at some point in time. So it becomes really more of 80% finished and 20% of the unknown that you're putting in there. And we also would like to more so partner with companies that actually have specific expertise in certain processes that they can do. We're not interested in doing all of ourselves. I don't think we can. We much rather would partner with somebody saying is, okay, you develop the process and we develop the base machine and help you getting it out there. And then, of course, anytime we have a useful feature that we have developed for customer application, we then would like to standardize it and to finesse it and to make it better for future use and proposing it. Over the years, I mean, I think my mantra always has been a robot should adapt to an environment and not the other way around. And same goes with that robotics and humans should work in unison and not be in each other's way. What I mean by that is, as much as we can, we're trying to live with or work around the current conditions and not try to adjust the conditions too much. For example, in the soil scooping system, we really worked with the customer to use their current containments of the soil and not ask them to modify them. Because yes, they were not perfect, yes, they were not ideally, but the cost and the complexity of changing thousands and thousands of containments that they already have in place would be probably not valuable. Same thing in a let's say on the strawberry farm. If you put too many things in place, conditions that you need to put certain guardrails or certain markers onto the system for navigation, it becomes very, very difficult for them to implement that and becomes very costly. So we're trying to see at the current condition the way it is and trying to work with that and do our best to work around that, basically. We do also believe that nobody can do it alone. So we do, like I mentioned before, we do like to collaborate and use the expertise of others. It's very important to us whenever we can. We'd rather not do it ourselves. And I think we also always go under the presumption that we know robotics, but we do not know plants and crops. So we're looking for feedback from growers, from other people with experience that help us understanding that. We're not claiming that we know exactly what they need and what is actually required. And our motto has always been to work on MVP. In this case, actually stands for minimum viable process. That actually you develop something that actually it gives some value to the growers, and then you keep perfecting it and expanding it after that. But not try to overpromise and not try to over extend yourself that you can never get to an actual delivery side of it. So we are still looking for partners and for different aspects that we are not really the greatest for. Data, for example, is not something we have been tackling yet on a great side of it. And I know there's some people in this group here that could definitely help. Navigation is an aspect that we'll keep trying to get better and better. We have some rudimentary navigation built in that works for the current condition, but I think we have to do a much better job. Vision is still a big aspect of it. It might be scouting or crop identification or yielding, other things are still very much of something we would like to do. And then we would like to know, of course, from growers here in this group, what are specific process applications that you see valuable? What is it actually that would make sense to you, that would make sense to develop and to go into, that can be adapted towards? How are we doing with time? Are we good for 5 more minutes, 2 more minutes?
Sorry, I was muted.
Right.
Yeah, you're good for a couple more minutes.
Okay, perfect. So calibration, I kind of mentioned this a few times, but I think I really would like to stress that is actually the most important part, especially in this industry, I find. When I mentioned before that the first AgroTrax, the scouting robot was brought forward by Greg, obviously, for going to the greenhouse for scouting. That is only partially correct, because the other part actually is he did mention it to me, but the project only happened once we actually IRAP brought a project to us and said, could you picture doing that kind of stuff? And we said, well, yes, we can. And then we went back to Greg and said, can you help with this, basically? And of course, the project with IRAP only developed through some other connections that we had previously that we have worked on, where we helped some other companies in the ag business to develop some products. And so that relationship came from there. So all of these things actually all happen through relationships. Nothing happens by itself. Then, of course, we got Great Lakes A&L work on this project together, IRAP. Eventually, IRAP helped us on the strawberry side as well to identify those projects. And we're working now with BGO and with OMAFA on those projects. And then we need other partners to help us in. Haggerty, Chuck has helped me sometimes to bounce off ideas off him and help me, finding different ways how to do things on the technical side. Joe Dales, sometimes on the business side, we have a chat and we talk about things. And not last but least is actually Fancha has been very instrumental on this part. And I really would like to shout out to them as well. Because they actually helped us on the navigation side, getting us on where we are right now at the moment. So they have actually a very great team. If anybody needs any help, they've been doing a really, really good job. And I think without collaboration, without us all working together, none of these things could really happen. So with that in mind, I would like to ask this group if anybody, has interest or wants to work together. We're definitely looking for applications for different things that we can do with our systems. But then we're also looking for collaborators on the technology side who can provide which kind of, like I mentioned before, data, vision, and so on, who can help there. Funding is always a big aspect, and I really appreciate this group here for putting out the funding opportunities out there. But even so, we're engineers sometimes. The funding side is not really our strength, and the funding side is still something we need to work on. Sales and marketing. I always say I'm more an engineer. Sometimes I'm finding it not that easy to sell to growers. I'm not always sure exactly what's required there. We do not have a great IP strategy at this moment. I'm not sure if anybody can help on that side. And just in general, we're looking for advisors, people who can help us. Like we're already talking to some people, like I said before, but we're definitely interested in having your opinions and listening to what you thought, where it could get better and could get stronger. And last but not least, we are definitely open to partnerships as well. We don't have to go it all along. We're right now at the moment, Konnexio, and this aspect is owned by me only. But I realize alone it's very hard to go it all alone, and it's very difficult. And I mean, I have engineering qualities, but I have maybe some other things where I could definitely use some help and some people that can be of assistance as well, or work together. So with that, I would like to thank everybody for joining here, and looking forward to having a good discussion about these things.
Excellent. Thanks so much, Konrad. Really appreciate that.
Messi, come on.
Sorry? Oh.
That wasn't me. Sorry.
No, it was I think it was a mistake on someone else's.
Yeah, it must have been, yeah.
So we did have one question for you in the chat that came through.
Okay.
Someone was just wondering when you mention UVC dosage, what exactly do you mean by that?
Yeah, so we trying to verify how strong the UVC at a certain distance. Of course, the dosage means that you have a certain strength of the UVC lights. The further away you go, the less it is. And what we're trying to establish is how fast are we going to be driving past? So how much radiation is going to be applied to the strawberry plants? If you stay too long, the dosage could be too high, and then you could have adverse reactions to what you actually want to achieve. So we need to kind of apply a certain amount of UVC, and therefore we're doing that basically by controlling our speed. So we have a controlled method how we can drive faster or slower. The grower can set that actually, but we also need to measure first the strength of the UVC lamps before we know that. And there's a calculation factor for that. Don't ask me, I'm not a scientist, but there's a factor can be set up, and then we know exactly what the dosage would be, and then we can probably vary from there. We're probably setting that, and we're trying different parameters. A little bit faster, a little bit slower to verify, okay, at that kind of dosage, what was the feedback, what was the reaction on that, and if you go faster or slower, what happens then?
Excellent. I'll throw the question over to Dhruv, but then I'll cut it off there just so I can get through the rest of the agenda. And then if there are any more questions for Konrad, we'll come back to them in the rounds table section of the meeting. So Dhruv, please go ahead.
Thank you. Great presentation, Konrad.
Thank you.
I just wanted to ask at a higher level, what are the most common vision-related problems, or what kind of applications do you need help with? Come from a vision background, so just was curious to understand.
Well, I think the biggest thing is crop identification is probably what yielding, for example. I've seen that a lot of having interest. And then, of course, the other thing is scouting. But when it comes to scouting, the question is to what level. Then it's more kind of like finding the certain diseases on a plant, which can be difficult sometimes. It can come down to very minute little insects or diseases, identifying them, what they are, for example. So that's usually been a big issue as well. What I've seen anyways. But again, it comes down to the growers, what they're looking for, what are they trying to identify.
Perfect. Thank you. I'll reach out and we should talk more.
Perfect. Thanks.
Excellent. Thank you. And Konrad, thank you very much for your presentation, for your time this morning. We really appreciate you.
Thank you. Thanks.
Yeah, so as I said, if there are any more questions, please save them for the round table. Just got to get through a few agenda items before we get back to that. We do not have any new upcoming events or demonstrations, but all the registrations are open for the upcoming ones in the summer, so please definitely check those out. For project updates, so to this week we sent out the first, most of you, all of you, hopefully, I suppose, should have seen 2 emails come through regarding the agenda for this week. They would have looked slightly different, but on the grand scheme of things, had the same information, the link to the Zoom meeting, as well as it would have had the agenda attached. I guess I just want to see, is there anybody that didn't get the slightly different email? No? Okay. That's good. That's good. We want that to be the answer. Okay, perfect. So that's so far at least seems to be all good on our end. So yeah, please keep that in mind that it'll look slightly different going forward. But it'll all be the same. Bridget, I don't know, did you have anything you want to add on to that, or did that pretty much cover it?
No, we actually cleaned up the email a little bit just to put less in the body of the email. So if people really liked having lots of stuff in the body of the email, let us know. But Dan and I felt having the attachment is the easiest way to get the info. So thanks, Dan.
Perfect, thank you. No new funding announcements or opportunities for this week either. So with that, we'll head on over into the round table and open up the floor for questions, comments, thoughts. Garrison, you had your hand up, so go ahead.
Yeah, thanks, Dan. Garson along with Kane. I just wanted to bring to everyone's attention a little bit of an update on the funding opportunities list. It's listed there as our 2024 open competition. We've actually closed that competition now, but we have opened up four separate thematic competitions, and these are specific to broadacre as one, small acre and controlled environment as a second, primary processing as a third, and livestock as a fourth. So I'll just drop into the chat and update, and I'll make sure you have the information for subsequent agendas, Dan.
Carson, what's the ideal group to apply for that? Can you just really be a bit more specific on what would be ideal?
Everything in the digital ag space. So I think what Konrad spoke about today would be a prime example of the type of technologies or type of activities that we would be able to support. Otherwise, it's everything that's in the digital space that's related to those fields, robotics, automation, artificial intelligence, database decision making, smart farm activities. All of our funds are geared towards supporting Canadian SMEs and partnerships in particular. Projects can take place either regionally, or they can take place across regions, or they can be national in scope. So, because we're a national organization, we're able to support activities that take place either in a very specific area or for that span different partners across different regions.
Excellent. Thanks
Thanks,
for the
Joe.
update, Carson. Sandra.
Hi. Can you hear me well?
Yes.
Okay, fantastic. I just wanted to make you all aware of a call for international co-innovation with Singapore. So I'll post in the link. This is launched by IRAP, and it is for Canadian companies that want to collaborate to create innovation with companies in Singapore. And agri-food, agri-tech and food security is one of the topics that they are opening this collaboration for. So I'll put in the link, and if anybody has partners in Singapore that they're working with or would like to explore that, check the website for sure.
Excellent. Thank you.
Thank you.
And when are applications due for that, Sandra?
The deadline for registration is June 2nd, so it's coming up pretty quickly. And deadline for expression of interest will be June 16th. And then after the expression of interest, then it goes up to the committee that will evaluate those expression of interest and then tell the companies that were selected to invite them for a proposal. And that will be September 1st deadline.
Excellent. Thank you. So get on that quick if you're
Yeah.
it's something you're interested in. Perfect. Okay, we did have going back to you, Konrad, just a question that came up for you in the chat was have you considered pest control with your robots?
No, I'm not sure exactly what is required, but would love to have a talk about it. Yeah, would love to think about what would be required or what they're looking for sure.
Gotcha. Okay, were there any other questions or thoughts?
A couple of news items that this group should be interested in. FCC announced a $2 billion ag tech innovation venture capital fund. Graham Millen will be, I think, speaking in a few weeks here. So, do you know have the date on that, Dan? Because people should put that on their, on their calendars.
Yes.
So that's pretty exciting. That's a lot of dollars that FCC is committing to the innovation space here. So
the date for Graham's presentation is July 11th.
July 11th. So you won't want to miss that one. And then real life robotics. Cameron's been on a bunch of these. They announced this week that they're working with Skip the Dishes in Markham to actually have their robots doing home delivery. So that's pretty, pretty interesting to see. So we'll see how that proceeds over the next few months. And then Peter King's been on a bunch of these calls. He's in London here. Cypher Robotics just landed Air New Zealand for their big warehouse robotics system. So I talked to him the other day. He just got back from New Zealand. So that's a huge company builder client that they picked off. So a couple of our members here are starting to get some interesting traction, and we know how hard it is, Konrad. I really appreciated your frank honesty, and you've been a real warrior for trying stuff. And I think, I was impressed with, where you are and where you're heading. So hopefully this group can all step up and find ways to support, entrepreneurs that are putting their blood, sweat, and tears into products like your ag tracks and stuff. So,
well, thank you. Thanks. I mean, it takes a village, basically, right? It's always good to chat with you as well whenever you have a chance to talk about business, the ag business.
So yeah, lots of good stuff going on.
Awesome. Yeah, definitely. Thanks for those updates on that stuff, Joe. All right, we're coming up to our time here. Was there any last quick thoughts or questions before we call it for the day?
Is Kate still on from Haggerty? Because I don't think Chuck's on this morning. He's going a million miles an hour. But Chuck told me that his team was really doing well getting the other robots working and troubleshooting. And, we know how hard it is at this time of year because the shit hits the fan and everybody needs it done immediately. So, there's Jeff. How's everything going at Haggerty, Jeff?
Yeah, great. Everything's going really good. So actually just sold a robot this morning. So we're just we had the big rush of spraying and getting everybody's robots delivered, and it all went well. The manufacturing and the retrofitting of some of our custom spraying units, things like that is going really well as well, all on track. We have run into some service issues, which is to be expected, but nothing too out of the ordinary, and people are generally very happy.
Awesome. Glad to hear it. Thanks, Jeff.
Yeah.
All right. That'll bring us to the end of the meeting for this week. Everybody, thanks so much for your participation. Konrad, once again, thanks so much for your presentation. Really appreciate you taking the time. Hope everybody has a great weekend, and we will see you in June.
Thank you.
Bye, everybody.
Thank you.
Bye. Thank
Thank
you.
you.
Everyone.
Take care, everyone.